Hey, welcome back to another geometry lesson. Mr. Natsky coming to you from the basement of his house again. It's week 7. Today we're going to talk about area of two-dimensional figures. This is kind of a precursor, and we're going to talk about nets later on in the week. To the next 2 weeks, we'll wrap up by finding surface area and volume. It's kind of key to help us to set up so that we could do those two topics as we cover them. Before we get started, just a few announcements, reminders. Remember, everything can be found on your Schoology page. You scroll down to week 7. You got the week 7 folder. We're looking at test number 1 today. In the unit 5, 6, we renamed it because we're now starting unit 6. All the independent practice submissions that you have to do in Schoology can be found in that folder. You can click the arrow to drag it or click to open it up. They're all in there. We're in week 7 here. Hope everything's going good for you. And hang on in there. A couple more weeks left, and we'll be wrapping this up, and we'll wrap up the school year, and we'll move on to brighter, sunnier days. Better days are ahead of us. Hang in there. We are too, and we'll just keep working and doing our best, because that's what we do at Wanakee. So if you want here, you can go ahead, print the blank notes. Click on that link, it'll open up for you. You can go ahead and print that out. If you can't, again, you can just follow along on paper, jot the stuff down. For that, one thing I would recommend if you're jotting down, do take one sheet as you see this slide for area formulas, and we will use that predominantly as we go through and do this. There's also a link to the completed notes. You can go ahead and click on that. And then we've got our worksheet here. And if you're not using Schoology, again, we do still have the week 7 Google Doc where you can click on that. All the links are in there. It's got our welcome letter, which you'll be sent an email on, and all the tasks are right there that you can go ahead and click on the links and open them up. It's got the grading guidelines. Check them over again as we're winding down here. Remember, it's pass-fail, but you have to meet that minimum of a 60% overall, and both for the online learning. And as you watch the video, remember at the bottom in the description, okay, if you click on show more, there are the times. By clicking on the times, it'll take you to the links for specific examples and shapes and different spots in the video, allow you to skip around. And again, we have office hours. They're right here in the Google Doc. You can also find them on the Schoology page. Okay, just click on the link. Do note Mr. Vestbach did change his office hours. So if you're going to go see him, working on his schedule, it worked better for him to go a little earlier. So he's now from 10:30 to 11:15 every morning. Monday, Tuesday, Wednesday, Thursday, and Friday. So we're going to start area two-dimensional figures. Again, if you have any questions on last week's independent practice, on the quiz or in the circles worksheet, if you have questions on what you got wrong or where you lost points, go ahead and stop in, see your teacher during their office hours, send them an email, set up an appointment, join them on there, and you can talk through that and just stop in and say hi. Miss seeing a lot of your faces. A lot of you haven't seen now for 2 months. It'd be nice to see you. Say hi. See what's up. Before we get started in this unit, one thing we're going to talk about when you talk about area, surface area, and volume, which is the next couple weeks. When you're writing this out, obviously we will not be able to see your work, but you should get in the habit of, for every single problem, write a formula. Which formula are you using to solve the area, surface area, volume? Write an equation and work. Put in the numbers. You'll see as we do it on the video here in the notes. Jot that down every single time. And remember to always put units on your answer. And that will be part of your answer in Schoology. You should have seen it on the circles. There were questions that said, hey, what was the unit of measure for the previous problem? You have to click on that. So make sure we're doing that. Before we get started, let's just talk about and define. What is perimeter? Perimeter of a polygon is the sum of the lengths of its sides. It's the distance all the way around the outside. In a circle, it's the circle's circumference. Okay, it was a one-dimensional unit of measure. Okay, so when we're talking about a unit, it's either feet, inches, centimeters, meters, etc. One-dimensional. Well, now we're going to look at area. We're going to combine, we're going to multiply some things together. The area is a measure of the space covered by a two-dimensional polygon. Polygons are two-dimensional. They go measure two different directions. So therefore, when we ever talk about the area of a two-dimensional figure, it's going to be feet squared, inches squared, centimeters squared, meters squared. Here we've got the area formulas. As we go through our notes here, we're going to come up with all these formulas. Just a quick note, we did talk about a circle last week. Remember, the area of a circle is pi r squared. And the area of a sector in a circle, well, it's just a fraction of the circle. So it's m, which is either the measure of the arc or the central angle, divided by 360 times pi r squared. Those we did talk about last week. Area of a rectangle square. Remember, the area of a rectangle is base times height. You've been talking about this for a long time. You might also heard it as length times width. We're going to define it as base times height. But what about a square? Well, square is a special rectangle, right? So you could also use base times height. But what do you know about the relationship between the base and the height of a square? What do you know about the base and the height? Well, all four sides are equal. So they're the same length. They have the same measure. So if I did base times height, say we call it side, call it s, it'd be s times s. Well, another way to write that is s squared. So a shortcut for a square is s squared. We can go back to our rectangle. Area is base times height. Area of a square then is s squared. Let's look at some examples. So find the area of rectangle ABCD. What's our formula? Area is base times height. Well, what's the base? Yes, the base is 4. What's the height? 3. So it's 4 times 3. What's 4 times 3? 12. And we need a unit of measure. Remember, it's area. It's two-dimensional, so it's 12 centimeters squared is our answer. How about square? How do I find the area of a square? Well, it's s squared. All sides are equal in a square. What's the length of each side in this particular square? 9. So my area is going to be 9 squared. 9 squared means 9 times 9. 9 times 9 is 81 inches squared. We take the unit of measure, and it's inches squared. So as we talk about the one-dimensional versus two-dimensional, one-dimensional is measuring a length or a distance. Now, when I find an area, I'm taking two distances and multiplying them together. That's why I get the unit of measure squared. So I have 81 inches squared. Remember, a rectangle is base times height. What about a triangle? Well, notice if I take a rectangle and I draw in one of the diagonals, what did I do to that rectangle? I cut it in half. And what did I create? Yeah, I created a triangle. So what do you think the area of this right triangle is going to be? Well, half of base times height. What if the triangle's not a right triangle? What if it's cute? What if it's obtuse? Got a little demonstration here using GeoGebra. Do you think 1/2 base times height works for all triangles? Well, notice and watch as I rotate this. I'm going to divide, so I'm drawing in the height, which is the altitude of the triangle. It's the red line, dotted line there. I'm going to divide this triangle into two right triangles. And as I flip those triangles, I just created a larger rectangle, right? Area of the rectangle is base times height. So therefore, is the area of any triangle, the area of any triangle will be 1/2 base times height. So it doesn't matter if it's acute or even if it's obtuse. One note I want to make, if it's obtuse though, in order to draw the height or the altitude of the triangle, I do need to extend that segment out. Okay, so it's going to be outside of the triangle, whereas the base though is still the measure of that side. It's not the measure from there all the way to it, it's just the measure from here. It's still 1/2 base times height. So we can go back, we've already got a rectangle square, we can add our triangle formula to our formula sheet, 1/2 base times height. Let's look at some examples. I've got two triangles here. First one's a right triangle. Area is 1/2 base times height. What's the base? Let's call 5 our base and 12 our height. Well, notice in a right triangle, depending on how you look at it, either one of them could be. So I'm going to do 1/2 times 5 times 12. The base and the height in a right triangle will be the two legs that I'm talking about. And we can just type that into our calculator. 1/2 or 0.5 times 5 times 12, and end up with what? 30. 30. Now notice I did not have a unit of measure on this. So we will call this and say it's 30 units squared. So if you're not given a unit of measure, we would call it units squared for our area. Example part B here. Got another triangle. So the formula again is 1/2 base times height. Well, what's the base? $14 will be my base. Now 14 goes from there to there. And the height, which one's the height? Remember, the height has to be perpendicular to the base. It's the altitude. And since the triangle is obtuse, I do have to extend it out to get the height. 8 is going to serve as my height here. So 8 is my height. So I have 1/2 times the base, which is 14, times 8. Type that into my calculator. 1/2, 0.5 times 14 times 8 equals 56. 56, the unit of measures meters. .56 meters squared is my answer. As we move on, the next shape we're going to look at is a parallelogram. Well, we've got two examples here. I'm going to show you a little demonstration here in GeoGebra. So I've got a parallelogram here, right? Notice if we slide it, I have now drawn in the height, which is the distance between the two sides. It's perpendicular to two of them. If I take and cut my parallelogram in half at that point and I slide it over, what did I just create? A rectangle. And how do I find the area of a rectangle? Base times height. Another demonstration to find the area of a parallelogram is, notice the area of a triangle is 1/2 base times height. Well, what I'm going to do is I'm going to copy this triangle and I'm going to rotate it around the midpoint of one of the sides. What shape did I just create? A parallelogram. So can I just multiply The area of a triangle times 2? Yeah. So 2 times 1/2, well, they cancel out, become 1, so it's just base times height. So the area of a triangle is base times height. So our parallelogram, sorry, we can go back to our formula sheet and add in base times height to that as well. Let's take a look at some examples of some parallelograms. So I've got the first one here. Remember our formula is base times height. What's the base and what's the height? Well, which side? Well, height is the distance between two sides. So let's start by identifying the height, which is 9, right? So the base has to be the side that's perpendicular to the height. So therefore 20 is going to be my base, not 16, because the height is perpendicular. So my base and height are 20 and 9. So the area is 20 times 9. Type that in your calculator. You get 180 centimeters squared. Example B here. Again, my formula is base times height. What's the base? Well, 6 is the height here. Which side is perpendicular to the height? 15. Notice we usually say the bottom is the base, but opposite sides in a parallelogram are the same. So these, both the top and the bottom here, are both 15. They would both be considered the base. So the area is 15 times 6, which is 90 inches squared. Our next shape we're going to look at is a trapezoid. So we've got some demonstrations here in GeoGebra. Notice it says area of a trapezium, which is the English version of trapezoid. They give me the formula here, but how do we get that? Well, notice if I rotate this, I have a parallelogram. The area of a parallelogram is base times height. Well, the height is h. Well, the base is a plus b, which are the two bases of the trapezoid. And the trapezoid then is actually half of the parallelogram. So I'm going to take 1/2 times the area of the parallelogram. So it's 1/2 times h times the quantity a plus b. So I'm going to add the two bases together and multiply by 1/2 times the height. So it's 1/2 times height times. The other option we can look at is, what if I take this trapezoid and divide it into two triangles? Well, the area of the purple triangle, or blue triangle it says here, is going to be 1/2 a times h. The area of the red triangle would be 1/2 b times h. Well, if I add them together and doing a little algebra, I end up with 1/2 times h times the quantity a plus b. Another demonstration with triangles. So if I have a trapezoid and I create it, what I did is, notice they got the midpoint here, and we'll see that here in a minute, is, and I thought this is kind of cool, if you take one side and connect it to the other side, I'm going to take that triangle, small triangle I created, and I'm going to flip it and rotate it around the midpoint of that side. And what did I just create? A triangle. Area of a triangle is 1/2 base times height. H is the height. Well, the base are the two bases of the trapezoid added together. So 1/2 times the height h times the quantity b1 plus b2, where b1 and b2 are the two bases. We can go back to our first page and add that formula as well onto our formula sheet. Let's look at some examples. What's the formula? 1/2 times height times base 1 plus base 2. What's the height? I've got a lot of measures here. The height is the distance between the two bases. It's perpendicular to the two bases. My height is going to be 9. So my height is 9. And the two bases in a trapezoid are going to be the two parallel sides, which are 15 and 22. Now, it doesn't really matter which one I call base 1 or base 2. So I'm going to take 1/2 times the height, which is 9, times the two bases added together, 22 plus 15. Now, you can add the bases together. 22 plus 15 is 37, and then multiply together. 1/2 times 9 times 37. 1/2 times 9 times the sum of the bases, which is 37, and I end up with 166.5. Or you can also type it in as once, do 1/2 times 9 times, then we can just put in parentheses. I don't necessarily need to know what the sum of the bases is. I can just put in parentheses 15 plus 22, close the parentheses. I still end up with 166.5 is the area. Square inches is the area of the trapezoid. I have a park in the shape of a trapezoid shown below. Find the area. I want to express my answer as a fraction. So what's my formula? Area is 1/2 times the height times base 1 plus base 2. Remember, the bases are the two parallel sides. So 1/4 and 1/8 are going to be my two bases. Sorry, my clickings don't really want to work here. Well, what's the distance between those two bases? Notice 1/4 up here. Even though it's a side, it is perpendicular to the two bases. So 1/4, this quarter at the top, is going to be my height. So I have 1/2 times the height, which is 1/4, so I have 1/2 times the height, which is 1/4, times base 1, which is 1/8, plus base 2, which is 1/4. Add the two bases together, 1/8 plus 1/4. If I get a common denominator, it's 1/8 plus 2/8, which is 3/8. So I have 1/2 times 1/4 times 3/8. It did ask me to put this as a simplified fraction. Multiply the numerators. 1 times 1 times 3 is 3. Multiply the denominators. 2 times 4 is 8. Times 8 is 64. My area is 364 square miles. What about a kite and a rhombus? What do these two quadrilaterals have in common? They have perpendicular diagonals. So the formula we're going to look at next works when I have perpendicular diagonals, which does also mean if you wanted to, you could use this formula on a square as well. So I'm doing a little demonstration. How do we get this? So it tells me the area of the kite is 1/2 times d1 times d2. So it's the product of the two diagonals. Well, how do I get that? Well, if I rotate these, I get a rectangle, right? What are the dimensions of the rectangle? Well, d1 is one side of the rectangle. Diagonal 2, d2, is the length of the other side. And since it's base times height, and this was half of it because I've got 4 triangles that I divided into, and I doubled by rotating them. So it's half of d1 times d2. So 1/2 times d1 times d2. We can go back to our formula sheet. 1/2 times d1 times d2. Second example, example number 5. Find the area of the following figure. It's a kite. 2 sets of consecutive sides are equal. What's the formula I use? 1/2 times d1 times d2. Diagonal 1 times diagonal 2. So if I look at this, does it matter which one's diagonal 1? No. I called 28 diagonal 1, 34 diagonal 2, so I have 1/2 times 28 times 34. We're multiplying. Does it matter the order of multiplication? No. So I can type that into my calculator. 1/2, 0.5 times 28 times 34, and I end up with 476 yards squared. Part B, if KT is 36 and IE is 24, what do I know about 36 and 24? They're the two diagonals. And they're perpendicular because it's a kite. So how do I find the area? 1/2 d1 times d2. 1/2 times 36 times 24. Type that into my calculator and end up with 432 millimeters squared. Next, we're going to look at our next shape is a regular polygon. Let's remember, what is a regular polygon? It is a polygon where all angles have the same measure and all sides have the same measure. Doesn't matter how many sides there are, but all sides and angles will be the exact same measure. Let's come up with a plan to find the area of each of these regular polygons. Let's think about this here for a minute. How am I going to do this? What do you think I should do? Did I hear somebody say, let's take these shapes and divide them into triangles? Well, maybe I was hearing things, but that's what we want to do. Notice I've taken the pentagon, the hexagon, and the octagon and divided them into equal triangles. Notice all those triangles are equal. And do we know how to find the area of a triangle? You betcha. So what additional information would I need to know? I need to know the height of each one of those triangles. Well, how could that help me? Because if I find the area of each of the triangles, I can multiply that area by the number. So I only need to find the area of one of those triangles. Well, what we do is when I get the height here, I call this in a regular polygon, we call this the apothem. It's kind of like I say the radius in a circle. Well, the apothem represents two things. It's the shortest distance from the center of the polygon to the side. It will be perpendicular. And this point here is also the midpoint. Okay? But it's also, more importantly, it is also the height of each one of these triangles. And S, which is the side length, is the base. And that's the same for all of these. Okay? Do note, not only did I divide this into equal triangles, they're all isosceles, which does mean the height, or the apothem, as we call it, will divide the triangle in half. So how do I find the area? Well, what I want to do is take the number of triangles and multiply by the area of each triangle. Well, the number of triangles, how do I find the area of each triangle? 1/2 base times height. Well, the base is represented by what? S, because S represents the length of each side. And A represents the height of the triangle, which we call the apothem. So S represents the length of a side, A the apothem. So when I have a formula for a pentagon, it would be 5 times 1/2 S times A, because there's 5 sides. Well, what about any other regular polygon? We're going to take N. Multiply that by 1/2 times S times A, where N represents the number of triangles, but do note it's also the number of sides. If I have a pentagon, 5 sides, I'm going to divide into 5 triangles. So if we go back and add that to our last formula on our sheet we haven't talked about, it's N times 1/2 times S times A, which is also the number of triangles times the area of each triangle. So let's try some examples here. Notice the first letter A, I've got a pentagon. It's the number of triangles times the area of each triangle. Well, how many triangles am I going to divide this into? It's N. The area of each triangle is 1/2 S times A. Well, how many triangles am I dividing this into? Well, it's a pentagon. How many sides does a pentagon have? 5 sides. So I'm going to divide it into, it's a pentagon, yes. I'm going to divide it into 5 triangles. 5 sides, 5 triangles. So it's 5 times 1/2 times what's the length of each side? Yeah, 8. What's the apothem? They tell me it's 5.5. So you can do 1/2 times 8. So you get 2 options here. Option number 1 is I can take 1/2 times 8 times 5.5, and I can find the area of the triangle to be 22. Do you need to do that? No. Okay. What I would just do in my calculator is, so I have 5, because that's the number of triangles, times 1/2 times the side, which is 8, times the apothem, which is 5.5, and I end up with my answer of 110 inches squared, which 5 times 22 is 110. Second one, area of a triangle, number of triangles. Times the area of each triangle. N times 1/2 times S times A. What type of figure is this? How many sides are there? 1, 2, 3, 4, 5, 6, 7. This is a heptagon. It's a heptagon because it has 7 sides. So I'm going to have 7 triangles here. What's the length of each side? It's 8. Is 9.2 my apothem? No. The apothem does have to be the height of the triangle. Notice if I divide this into a triangle, is 9.2 actually the height of the triangle? No. The apothem is going to be right here. It has to be perpendicular to the side. It has to go through the midpoint. So I'm going to have to find this. Well, how am I going to do that? Well, I've got to use the Pythagorean theorem. So I've got to find the apothem. How am I going to do that? Well, I've got the red line, here's the apothem. What I need to do is do a squared plus b squared equals c squared. I know obviously this is 9.2. Well, 8 is the entire length of the side, but as I mentioned earlier, the apothem not only is perpendicular to the side, but it's the midpoint. It's the perpendicular bisector of each side. So that would be 4. So a squared plus 4 squared equals 9.2 squared. A squared plus 16 equals 84.64. Subtract 16 from both sides. Take the square root. What's the apothem? 8.2849. Now I'm going to use 4 decimals here because I don't want to round till I get to the end. Using 4 will give me a more precise answer than just using 2. So I have 7 times 1/2 times 8, which is the length of the side, times the apothem, which is 8.2849. So if I type that into my calculator, 7 times 1/2 times 8 times 8.4, 8.2, sorry, 2849, I get 231.977. Staying with our habit of rounding to the nearest hundredth, I'm going to round this to 231.98 centimeters squared. Do want to make a note. If you would have used 8.28 instead, you would have got an answer of 231.84. So notice I'm off a little bit by using it. And if I use the exact number, I would still get 231.98 as well. So now I've got some problems where they're going to give me the area and I want to find some measures. Working backwards, as we call this. If the triangle of area LON is 150 meters squared, find IN. Well, what is IN? It's the height. Well, how do I find the area of a triangle? It's 1/2 base times height. But what's the base? 20. Notice they give me 8 and 12, but 8 is one side and 12 is the other, so add them together, I get 20. I don't know the height, but I do know the area is 150, so I'm going to put 150 in for A. I now need to solve for H. Well, let's combine like terms on the right side. 1/2 times 20 is 10. How do I get 10 by itself? Yeah, how do I solve for H? Yeah, divide by 10. Divide both sides by 10. The 10s will cancel on the right. 150 divided by 10 gives me a height of 15 meters. So a rhombus has a perimeter of 84 centimeters and an area of 250 centimeters squared. Find the height of the rhombus. Now we did say you could find the area by doing 1/2 D1 times D2 because a rhombus has perpendicular diagonals. But a rhombus is also what shape? Yes, a rhombus is a parallelogram. Because opposite sides are parallel. But I don't know the length of each side. Or do I? The perimeter is 84. How do I find the perimeter? Add up all the sides. All 4 sides add to be 84. And they're all equal. So let's take 84 and divide by 4. Each side's 21. And I want to find the height. Even though this is a rhombus, it's still a parallelogram. So I can use the area of a parallelogram. Base times height. The base is 21. I don't know the height, but I know the area is 252. Can I solve for H? Yeah, divide by 21. 252 divided by 21. Gives me a height of 12. 12 centimeters. Now note both of these heights are lengths. They're one-dimensional measures. That's why it's just meters and centimeters. Example number 8. I want to find the height of a parallelogram. If the area is 45 centimeters squared and the base is 15, I want to solve for the height. How do I find the area of a parallelogram? Base times height. The catch here is I know the area is 45 and I know the base is 15. I can plug that in. I can solve for H. How do I do that? Divide by 15. 45 divided by 15 is 3 meters. So I have a trapezoid. It says find the missing base of a trapezoid where one base is 20, the height is 12, and the area is 180 inches squared. Do I have the formula for a trapezoid? Yeah, it's 1/2 times the height times base 1 plus base 2. Let's plug in the measures I know. The area, A is 180 times 1 equals 1/2 times the height is 12. I'm missing one base, so I'm going to leave that as B plus 20. Now, we just got to do some arithmetic. Let's combine these like terms. 1/2 times 12 is 6. Now, from here, I've got 2 ways to solve this. Option number 1, it's 6 times B plus 20. So I can divide both sides by 6. The 6's will cancel out. 180 divided by 6 is 30. So that equals 30 equals b plus 12. Subtract 20 from both sides. And the height is 10, or the base is 10 inches. Or the other option is what I can do when I get 180 equals 6 times b plus 20 is I can distribute the 6 to get 180 equals 6b plus 120. Subtract 120 from both sides. I get 60 equals 6b. Divide by 6 then. And I end up with 10 inches as well. Either way, they both work out. If you have any questions or any difficulties, remember stop in during office hours. Independent practice, week 7, task number 1. You can find it in Schoology. Okay. You can print out the blank worksheet by clicking on it and answer yours from there. And then submit your answers in Schoology. Week 7, task number 1. The area worksheet. One thing I want to point out is read your directions, because it's going to ask you for example. Like when it says to find the area or find the height or whatever it might be, only type in the numbers. So for example, when we give you find the area of a square with a side length of 8, well, it's 8 times 8, which is 64. So just type in 64, because the next question is then going to ask you what's the correct unit of measure. Multiple choice, it would be inches squared. And lastly, we have our extension. I want to find the area of a regular hexagon, but I'm only given the side length. I don't know the apothem, because eventually I want to find the area, right? It's the number of triangles times the area. N, 6, because it's a hexagon, times 1F. I know S is 4, but I don't know A. That's what we got to find. Well, what I want to do first is find the angle of each triangle in the center. So if I divide this into 6 triangles, well, notice all 6 of these angles in the center add up to 360. So I can take that and divide that by 6. But here's my apothem. That's going to also take this triangle and cut it in half. So I can take 60 and divide by 2 to get 30. So this angle I've got a picture here is 30, the apothem. And remember that the midpoint's 2. Can I solve for A here? Yeah, SOHCAHTOA. 30 is my reference angle. 2 is opposite. A is adjacent. That tells me I'm going to use what? Tangent. Tangent of 30 equals 2 over A. Multiply both sides by A. A times tan 30, divide by tan of 30. Tangent of 30 to cancel out. A equals 3.4641. So I can plug that in. 6 times 1/2 times 4 times 3.4641. And I end up with an area of 41.57 centimeters squared. I hope you enjoyed it. Hope you had fun. Thanks for joining me. Thanks for listening. Thanks for sticking around. Greatly appreciate it. And I hope to see you at some point. Stop in during office hours. We will see each other in person very shortly. Hang in there. We will get through this. We will survive, because we are warriors. This is Mr. Natsky signing off.